Hello students, greetings of the day. I hope you are safe at home. In last video, you have learned about distance and displacement, speed and velocity. What is speed? The rate of change of distance is called speed. Speed is equal to distance divided by time. Next, what is velocity? The rate of change in displacement is called velocity. Velocity is equal to displacement divided by time. Now we are going to study about acceleration and its types. Do you know what is acceleration? Acceleration is the rate of change in velocity. Acceleration is the rate of change in velocity. In other words, if a body changes its speed or direction, then it is said to be accelerated. In other words, if a body changes its speed or direction, then it is said to be accelerated. For example, changing speed. Changing speed. See here, let us assume that the car is going at a speed of 20 meters per second. The speed of the car is increased to 30 meters per second. The speed of the car is changed. This is the example for acceleration. Next one is change in direction. Here the car is going at a speed of 20 meters per second and the direction is changed. So we can say that the car is accelerated. Next one is change in both speed and direction. Here the speed of the car is increased 20 meters per second to 30 meters per second. And the direction is also changed. This is also an acceleration. In the first case, speed is changed. In the first case, speed is changed. In the second case, the direction is changed. In the third case, both speed and direction is changed. Another example, suppose if you drive a car, how will you accelerate it? How do you change its velocity? There are three ways to accelerate a car. First one, if you press the accelerator, the car goes faster and faster. Speed of the car increases. First one, if you press the accelerator, the car goes faster and faster. The speed of the car increases. In this case, the car is accelerated. What is the second way to accelerate the car? We know acceleration is change of velocity. Now, change can be increase or decrease of speed. How do you decrease the speed of a car? If you press the brakes, the speed of the car is decreased. If you press the brakes, the speed of the car is decreased. This is also a case of acceleration. It is known as negative acceleration. It is known as negative acceleration. What is the third way to accelerate the car? What is the third way? If you turn the steering of the car, the direction is changed. If you turn the steering of the car, the direction is changed. That is, the velocity is changed. Therefore, the car is accelerated. Next, the formula for acceleration is equal to change in velocity divided by time. Change in velocity means final velocity minus initial velocity divided by time. Here A represents the acceleration. Next, B represents the final velocity. U represents the initial velocity. T represents the time. SI unit of acceleration is Initial velocity u is equal to 0. Since car starts from rest. Okay. Initial velocity u is equal to 0. Next final velocity. Final velocity v is equal to 12 meter per second. 12 meter per second. Next time taken 4 seconds. Time is equal to 4 seconds. Therefore, acceleration A is equal to final velocity v minus initial velocity u divided by time t. Substitute these values. V 12 meter per second minus u, that is initial velocity 0 divided by 4. 12 divided by 4. 12 minus 0, 12. Okay, 12 divided by 4. 3 4s are 12. Therefore, 3 meter per second square. Acceleration small a is equal to 3 meter per second square. Okay, next one, positive acceleration. If the velocity of an object increases with respect to time, then the object is said to be in positive acceleration. If the velocity of an object increases with respect to time, then the object is said to be in positive acceleration. For example, car starts from rest and velocity goes on increasing. When velocity goes on increasing, acceleration is positive. Car starts from rest, the velocity goes on increasing. When velocity goes on increasing, acceleration is positive. This sum also example for positive acceleration. In positive acceleration, the direction of acceleration is in the direction of velocity. Another example of positive acceleration is dropping down an object. For example, an apple. Its velocity goes on increasing as it falls down. So the apple has positive acceleration. Next we will see a negative acceleration. If the velocity of an object decreases with respect to time, then the object is said to be in negative acceleration. If the velocity of an object decreases with respect to time, then the object is said to be in negative acceleration. For example, car stops when brakes are applied. Car stops when brakes are applied. Thus, velocity goes on decreasing. When velocity goes on decreasing, acceleration is negative. Negative acceleration is opposite to the direction of velocity. Negative acceleration is opposite to the direction of velocity. Next, throwing up a ball is another one example of negative acceleration. Because as the ball moves up, its velocity decreases. Throwing up a ball is another one example of negative acceleration. Because as the ball moves up, its velocity decreases.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour, and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence, the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator, and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction.
Next one, uniform acceleration. What is uniform acceleration? An object undergoes uniform acceleration when the change in its velocity for every unit of time is the same. An object undergoes uniform acceleration when the change in its velocity for every unit of time is the same. Table shows a moving bus with uniform acceleration. Here, time and velocities are given. See here, in 1 second, change in velocity is 20. In 2 seconds, change in velocity is 20. Okay. When the velocity of the object is increasing by 20 meters per second, the acceleration is 20 meters per second square. When the velocity of the object is increasing by 20 meters per second, the acceleration is 20 meters per second square. When the velocity of the object is decreases, look here, decreases. When the velocity of the object is decreases by 20 meters per second, the deceleration is 20 meters per second square. Here the velocity is increasing. This is called acceleration. Here the velocity is Next one is non-uniform acceleration. What is non-uniform acceleration? An object undergoes non-uniform acceleration if the change in its velocity for every unit of time is not the same. An object undergoes non-uniform acceleration if the change in its velocity for every unit of time is not the same. This table shows a moving car with a non-uniform acceleration. Here, time, velocity and change in velocity are given. In 0 second, velocity is 0 and change in velocity also 0. In 1 second, velocity is 10 meter per second, change in velocity also 10 meter per second. In 2 seconds, velocity is 40 meter per second and change in velocity is 30 meter per second. Note that the change in velocity is not the same for every second. The moving car is undergoing non-uniform acceleration. Next we will see distance, time graphs. This figure shows a car traveling along a straight line away from the starting point O. The distance of the car is measured for every second. The distance and time are recorded and a graph is plotted using the data. The results for 4 possible journeys are shown below. First one is car at rest. Okay. Look here, time and distance are given. Since the car is at rest, when the time is 0, the distance travelled by the car is 0 meter. When the time is 1 second, the distance travelled is 0 meter and so on. Here also distance travelled is 0 meter. This is a distance time graph. Here x-axis indicates the time and y-axis indicates the distance. The points are plotted in the graph. Here the distance is a constant. Okay. Next one is car traveling at uniform speed. Now assume that car is traveling at uniform speed of 10 meter per second. Here time and distance are given. Here in 0 second, the distance travelled is 0 meter. In 1 second, the distance travelled is 10 meter. In 2 seconds, the distance travelled is 20 meter. And in 5 seconds, the distance travelled is 50 meter. When we plot the distance and time graph, will be a straight line. Here the distance increases 10 meter every second. Okay, next one is car traveling at increasing speed. Here time and distance are given. Here 0 second, the distance travelled is 0 meter. In 1 second, the distance travelled is 5 meter. And in 5 seconds, the distance travelled is 125 meter. Here the graph is not a straight line. It will be a increasing curve. Next one is car traveling at decreasing speed. Here time and distance are given. Here in 0 second, the distance travelled is 0 meter. In 1 second, the distance travelled is 45 meter. In 2 seconds, the car has to be travelled 90 meter. But the car has travelled only here the speed is decreased. The graph is a decreasing curve. Okay. Today you have learned about acceleration and its types. Today's homework: what is acceleration and its unit. Second one, define positive acceleration. Third one, define negative acceleration. Thank you students. We will see in the next video.